approximately 0.42 coulombs. Okay, we will now discuss a very important law in electric current, electricity, called Ohm's law. Now, what does Ohm's law deal with? Well, you remember, how will it be possible to make an electric current to flow through a conductor like this? An electric current can be made to flow in a conductor like this if we can produce a potential difference between the ends of the conductor. You see, it is the potential difference between the ends of the conductor that will set up an electric field in the conductor. And it is the electric field that then drives the electric current. So, Ohm's law is a relation between potential difference between the ends of a conductor and the current passing through it. What do you think is going to be that relation? What happens when you increase the potential difference? When the potential difference increases, the current also will increase. Is that right? Okay. Well, the rate at which electric charges drift through a conductor depends on the potential difference V between its ends. That means the current I in a conductor depends on the potential difference V. And Ohm's law is a relation between these two quantities. Greater is the difference of potential, greater will be the current through the conductor. The relation between current and potential difference is given by Ohm's law. Now, you can actually write down Ohm's law on your own. Current will be directly proportional to the potential difference. Is that right? Or for most conducting materials, the potential drop between its ends is proportional to the current in it. As the potential difference increases, the current also will increase. How do we write that? This statement is what we call Ohm's law, and we can represent it symbolically. How? We have the statement of the Ohm's law is this: V is proportional to I. And you know, in science, anytime you have a proportionality sign, it can be replaced by an equal sign. Is that right? An equal sign adding a constant. And there you are, the statement of the Ohm's law. The potential difference is directly proportional to the current, or the potential difference equal to a constant times current, or V equal to Ri. V equal to Ri is actually the statement of Ohm's law. And there are three important quantities there. This constant R is called the resistance of the conductor. In other words, any conductor offers a resistance for the flow of electric charges. So that R is a measure of the resistance of the conductor, which is a constant for a given conductor. It can change from conductor to conductor, but for a given conductor, it is a constant. So what are the three quantities that is defined by Ohm's law? Potential difference between the ends of the conductor, the current flowing in the conductor, and the resistance of the conductor. V equal to Ri. Now, R is a constant and is called the resistance of the conductor. And R, if you want to solve R from here, R equal to V over I. What is the unit for measuring resistance of a conductor? Unit will be volt is measured, well, potential difference is measured in volt. Current I is measured in ampere. So resistance will be measured in volts per ampere, and it is called the ohm. And we will represent that by the uppercase omega. Greek letter omega. So resistance is measured in a unit called ohm, represented by the uppercase omega. 1 ohm is the resistance of a conductor which has a current of 1 ampere in it when there is a potential difference of 1 volt. So if I can produce a potential difference of 1 volt between the ends of this conductor, and at that time if a current of 1 ampere flows in this conductor, that means the resistance of this conductor is 1 ohm. That is the definition of resistance. And very often a conductor is referred to as a resistor, because it has a resistance. So a resistor, which is a conductor that has a resistance, is represented by the symbol. Look at the symbol we use for a resistor. Remember, this represents a conductor which carries a current. It is called a resistor because it offers a certain resistance for the flow of current. Now this is the symbol for a resistor in an electrical circuit. Well, you want to see a demonstration of Ohm's law? I will show it to you in a minute. Now, what are the things that I need to demonstrate to you the concept of Ohm's law? First of all, I need a conductor. Well, I have been showing you the conductor, which is this. Well, this is a very inconvenient way of using a conductor. In fact, in this box, I have several conductors. Let me show it to you close up. Now, this box contains large number of conductors. Now, when I flip this switch up, I'm using a conductor which has a resistance of 1 ohm. If I now flip this switch up, I'm using a resistance of 10 ohm. I can go to any value. You can see if I'm flipping this switch, what is the value of the resistance I'm using? 400 kilo ohm. This is, now when I'm using that switch, that means there is in between these two terminals, there is a conductor which has a resistance of 400 kilo ohm. Now, when I use this one, that will be how much? 4 megohm. Now, I turn this off. I turn the 4 megohm on. It means if I now connect a cell, if I now connect a cell between these two, there will be a conductor that will have a resistance of 4 megohm between those 2 points. Well, what I'm going to do is I'm going to use a resistance of 2 ohm. You see that? I have turned the 2 ohm on, and I want to make sure that everything else is turned off. Only that 2 ohm is there. Okay, so this is my conductor that has a resistance of what value? 2 ohm. Now, what do I want to do? I want to set up a potential difference between the ends of that conductor. Now, what do you do to set up a potential difference? I connect a cell. Now, this is a cell which has a positive end and a negative end. Now, what I'm going to do is I'm going to connect the cell through a control device. This is called a variable resistor. This also is a resistor. You see that? A wire is wound on a frame. This is a very long wire. And this is a conducting wire which has a resistance. I'm using it as a control because when I move this, I can change the length of that conductor, changing the resistance. So, look at that. My battery connection comes to the variable resistor. And from there, I'm going to connect it to my conductor here, right? and then from the conductor I'm going to connect it to an instrument that will measure current. Now this is an instrument that measures current. What is the unit of measuring current? Will be ampere. So this instrument is called an ammeter. An ammeter. So the connection comes to the ammeter, and from the ammeter, where do I go? I go to the cell, and I'm going to make the connection and see if the ammeter reads anything. Well, let's have a look. All the connections are done, and I want to make sure that there is no other resistors on here, as I have a 4 megohm still on. Now, do you see, when I make the connection, I'm making the connection there's a current flowing in this conductor. You see, what I have done is, I have connected the cell so that there is a potential difference. I made a potential difference between the ends of the conductor so that when I make the connection, a current flows. Alright, I also want to measure the potential difference between the ends of the conductor. You see, where I am pointing are the ends of the conductor. The current goes in here, flows through the conductor and comes out this way. Now to measure the potential difference, I connect the voltmeter right across here. Now look at my voltmeter. I had kept it away. Now my voltmeter is going to be connected. I'm going to connect the voltmeter one end here, and the other end of the voltmeter will be connected over here. So I have now a voltmeter connected. Now can you see the voltmeter? Well, let me see if I can raise it up a bit. Well, that is the voltmeter. Okay, I'm going to now make the connection, and you can now see there is going to be a current value and a resistor, you see, the ammeter reads the current, the voltmeter reads the potential difference. Can you see those? And now I'm going to use the control. See what I'm going to do? I can change, look at that. I can change the current and I can change the potential difference. Watch this. When I change the current, the potential difference also changes, and I can make different studies based on that. I want you to watch the readings of the ammeter and voltmeter one more time. Now, is it possible for you to read these? What does the voltmeter read? The voltmeter reads 0.5 volt, and the ammeter reads 0.25 ampere. 0.25 ampere. Well, what does the resistance then equal to? What is 0.5 divided by 0.25? Is that 2 ohm? That is what I have put there. So 0.5 volt is the potential difference. 0.25 ampere is the current. Now I'm going to increase the potential difference to, let's see what